Well, hello everyone. My name is Chris Builder. I will be your instructor for Stat 875 Categorical Data Analysis. Let me begin by telling you a little bit about myself. I'm a native Nebraskan. I grew up in the Millard area of Omaha. Went to high school at Millard South, and I got my undergraduate in math from UNO. After I got done with that, I finally went out of state and got my master's and PhD from Kansas State University, both in statistics. Overall, this is the 17th time that I've taught this course. The reason why I've taught this course so many times is this is by far my favorite course to teach. This is the area that I do my research in. Now, just because I've taught this course so many times doesn't mean that I'm still teaching it the same way that I did back in 2002 when I first taught the course. The course has gone on under a number of different revisions. I think I'm at either the third or fourth, fourth revision overall. And over time, as I will continue teaching this course, I will continue updating and revising, of course. Before we get into the talk about the syllabus, let me say one more thing. Please feel free to call me Chris rather than Dr. Builder. I actually would prefer for you to call me Chris. Okay, so let's talk about the syllabus here. In terms of my office hours this semester, it will be on Tuesdays after we get done with our class, and Thursdays at 2:30 p.m. You might be wondering, well, how can we have office hours at the same time that we're going to meet? You'll see why shortly. Now, with these office hours, I'm available at least for the first 30 minutes for these office hours. The reason why I say that rather than saying, let's say 2:30 to 3:30 is because I want to encourage you to come to office hours at the beginning of the office hours. I'm also available by appointment as well. All these office hours will be done via Zoom. If, however, you're attending the class in person, you're welcome to come talk to me in person then on the Tuesdays. My email address, builder@uno.edu. And our corresponding course website is available through chrisbuilder.com. I will show you that website in a little bit. We will use Canvas some in this course, but not a whole lot. Most of the stuff that we would do on the web will be via my chrisbuilder.com website. Now, in terms of textbooks, I have actually written a textbook myself. My colleague Tom Logan, who's a professor in the Department of Statistics at Simon Fraser University, is my co-author on the book. And I wrote this book back in 2014 because I felt as though, through teaching this a number of times, that the book that I have been using before needed some updating, needed to be better. And so I wrote this book with my friend Tom Logan, and we had it published in 2014. Do note that I signed a contract in April of 2020 to write the second edition of the book. I'm not as far along in the second edition as I had hoped because of COVID-19, but I anticipate that a second edition will come out in about 2023. Why I wrote this book for Stat 875 here at UNL. This book is used by a wide number of universities outside of here, and so this is why then the publishers wanted me to put together a second edition of the book, because it's widely used. Now, let me back up here a second. So the number one book still in this area is by Alan Agresti. I should say number one books. And the reason being is because Alan Agresti, who's now a retired professor at the University of Florida, he's written two different versions of a categorical data analysis book. An introduction version and a higher version. The introduction version is typically what's used for a class like ours. The higher versions meant for PhD students in statistics only. Our class is meant for master's statistics students and also master's and PhD students from a wide variety of disciplines. After using his introduction book for a number of years, as I kind of mentioned, I decided we needed something different. And so that's what led to my particular book. It's kind of a long explanation, but the reason why I give that explanation is because you will see these other books being used. And also, his PhD level statistics book does contain more material than I have. It also contains material at a higher level than what I have in my book. I, for example, use his first edition of his book as a PhD categorical data analysis course. A number of universities will use his higher level book for PhD level statistics courses as well, or for a second semester of a categorical data analysis course too. Okay, enough about that. You do need to get the book though. We will use content out of it. Okay, so in terms of the prerequisites for this course, you need to have some kind of introductory stat course before, where you talk about confidence intervals, hypothesis tests. One particular course that will fulfill that need is Stat 801. Now, what can be useful to also have for a course is Stat 870 or the equivalent. The basic thing is that you need to have some exposure to regression models. Now, this is recommended, is not required. Again, I've taught this course out 17 times. Students who have not had a formal full semester of regression analysis still have done fine in my course. But what I have found over the years is that students who have not had this particular course or the equivalent, there's a higher proportion that struggle with the content in our course, Stat 875, than for those students who've had a formal full semester of regression analysis. So that's why the course is recommended. But again, it is not required. If you are concerned about your background and if you about whether or not you've had enough regression before, come talk to me. I'd be happy to talk to you about it. I've already talked to a number of you about it as well, and I think we've shown that yes, you are prepared okay for this course, but still, if you have questions, please come talk to me. In terms of grades for this course, we will have 2 tests during the main part of our semester. Each of those tests will be worth 25% of your overall grade. These tests will be computer-based, meaning I will have you download a Word file that contains our test questions. You will type your answers to the test questions in this Word file and then email it to me when you're done with the tests. These tests will be timed. You will be taking them during our normal scheduled class time. We'll talk more about tests later. But you will need to use like a statistical software package to help answer the questions that are on the test. If you've had me for a class before, like 801 or 850, for example, the tests are basically the same kind of format. We will also have a final exam that will be worth 20% of your overall grade. And then during the semester, we will have about 5 projects, and we will also have weekly quizzes available on Canvas that you need to complete. These projects and quizzes, this 30% of your overall grade is based upon the total number of points earned out of total number of points possible. So let's say, for example, there were 300 total points that were possible combined together for these projects and for these quizzes. And let's say you got 270 of those 300 points. That means this 30% of your overall grade is a 90%. So if you were to find your overall grade for the course, let's say you got a 95% on that first test. That's going to be 25% of your grade. You got a 90% on that second test. That's going to be 25% of your grade. And let's see, unfortunately, your grades keep on going down. You got an 85% on the final. That will be 20% of your grade. And then you got a 90% on the projects and quizzes part of your grade. That will be 30% of your grade. If you do the math that I just wrote out there, so you do the multiplication, you add it up, then that will be your overall grade for the course. Then to assign an overall letter grade, I use a standard 90 to 100, 80 to 90, and so on scale for A, B's, and so on. I do assign plus or minus letter grades as well, and they're assigned 2.5% from the traditional cutoff points. So for example, an A minus would be, let's say, 90 or above up to 92.5. And a B plus would be 87.5 up to, I have 90%, but basically 89.99999%. Now, in terms of these projects that we will have, you can think of them as, let's say larger than normal, let's say, homework problems. That's what these projects contain. And there will be about 5 again during the semester. All these projects need to be done electronically, meaning that I'm going to give you a Word file, and you can enter your answers in the Word file, or you can create a PDF document that has your answers in it alternatively, and then you email that to me when you're done. I will grade it electronically with the help of my pen, and also through just simply typing on the document itself. These projects are meant for group work. At least for the first project, I require you to work in a group. These groups can be up to 3 people in them. So you should start now thinking about who in this class you would like to work with. Now, I understand that you might not know anybody in this class, and that's okay. What you will see later here today, or at least I will start explaining a little bit later here today, I will give an opportunity for you to say, hey, I'm not in a group right now. Can you help me out and find a group? And I will be happy to form groups for those students who maybe do not have a group or do not know who they would like to work with. And again, at least for the first project, I would like everyone to work in a group. If you find out that, yeah, it didn't work out well for you, okay, you can work on your own, or you can find another group to work with. The maximum number of students in a group, again, is 3. Now, when you do work in a group, please take advantage of group work the right way. Let's first talk about the wrong way to do group work. So let's say that you have a group of size 3, and there are three problems on the group. And when the project's assigned, you say, okay, you get problem number 1, I'll take problem number 2, and you get problem number 3. You each work on them separately, and then 5 minutes before the project is due, you combine everything into one Word file without ever discussing any parts of the project together. You combine it, and then you hand it in. Again, that is the wrong way to do group work. The right way, there's a number of different ways to do this, is as follows. Option number 1. Each of you in a group of size 3 tries to complete all the problems yourself. Then you get together to meet, and you go through each problem one by one and come up with one final solution that your group then hands in. That would be one way to do it. A second way to do it is to each person, let's say again if there's 3 problems, each person gets one particular problem where they take the lead on it. They do it all themselves. And then again, you get together, let's say a few days before the project is due, and you go through every part of the problem, of each of the problems, and decide what your final answers will be as a group. So one of the beautiful aspects about group work, especially in these 2 options I gave you, there's again other ways to organize it, The beautiful thing about group work is that not only are you going to be learning from me, you can learn from your fellow classmates. That's why I'm a strong proponent of group work, and I strongly encourage students to work in groups. Okay, let's move on. So, to do our statistical calculations in this class, we will use the statistical software package called R. Now, for this class, there is no prerequisite that you have experience with R. I know most of you do, but there is no prerequisite for that. So what you will see in my notes and the corresponding videos that I have recorded corresponding to these notes, that again we'll talk about shortly, I do not assume any prior background in R, and especially at the very beginning of the notes, I go slowly to try to explain the basics of how to use R. What you will see on my course website is I have an introduction to R2 for those of you who are not familiar with R. This introduction is based upon Appendix A in my book here. So if you do not have R experience, the first thing that you should do after our class today is read Appendix A and also to go through the corresponding course notes and videos that I've set up to help give you that introduction to R. I will show you how to access this stuff later. And again, if you're not familiar with R, R is free. So you can download it from this corresponding website. All of our classes that we have in, either on Zoom or in person will be actually recorded so that you can come back and review what was discussed in class if needed. But please do not take advantage of the fact that all these classes are recorded by saying that you're just going to simply skip class. Now, I understand occasionally during the semester there may be times where it's like, yeah, I just can't go. Maybe I'm sick, for example. I'm not going to go to class. Here's your backup. Watch the videos. Our final exam is 3:30 to 5:30 p.m. on Tuesday, May 4th. This is the time that we will have the final exam. You need to plan for it. Please do not ask me to take the final exam earlier because I will tell you no. Now, expectations of students for this class. Understand all the material in the course notes. So I've put together an extensive set of course notes in Word documents to help you learn this material. You are expected to understand all the material that's in them. I wouldn't have typed it up. I wouldn't have put it in there if it wasn't important. Now, occasionally, there will be times where I will say, okay, don't worry about this. But otherwise, unless you hear me say that, you are responsible for all the stuff that's in the course notes. Now, as with any modern statistics course, especially one that's an applied course such as ours, there will be programming that will need to be done. Again, we'll be using R. And you're responsible to understand all the programming code and also the corresponding calculations, the output that's generated from this code. You are responsible to understand all aspects of that. There are many, many, many examples in my notes about how to use R code and output, but also how to do other things relevant to our course. Please reproduce all the examples on your own in the course notes. So as you will see as we go through the material that I have on my course website, I have my course notes and I have videos corresponding to all the course notes. What I recommend that you do is you watch the videos and then also at the same time have the course notes with you and take notes on them. You can stop the videos and reproduce then the corresponding examples then on your own. That would be an ideal way to approach learning in my course. And I just mentioned, well, we have some videos. With my course, I also have some additional problems for you to examine. I call those homework. They are not for a grade. You do not need to turn them in. Sometimes I'll put like old test questions on the homework, Or at times there will be some problems where, since this is an applied statistics course, there will be some stuff where I derive, like how does this statistic come about? Or why do we use this confidence interval? How did it actually come about? And at times I would put those in the homework so that you can still see what they are. With this course also, I give you some old tests that I've written in the past with an answer key. Also, I give you some old projects that I've written for this class with an answer key. So I strongly, strongly recommend then that you go through those old projects, you go through those old tests, and make sure that you know how to do every aspect of them. I guess this is one benefit of me teaching the course like this. I have these additional materials that you don't necessarily always have with a course. And then lastly, just to make sure that you understand this, please, please, please ask questions if something's not clear. I want you to succeed in this course. Please let me know if you're having problems with something, if something's not clear. I'd be happy to meet with you individually via Zoom, or to discuss it as a class as a whole, some of the material that's maybe not making sense. Now, with this particular, with any particular course at UNL, we're required to put some additional information on it. I put all this information to what I call a syllabus supplement. You can download that from my website, and I'll show you where to get that in just a little bit. Let me make sure that I discuss everything that I needed to here. So let me take a look at my notes. I think just lastly, one other thing I want to mention. In terms of statistics courses, this is what's called a mixed major course. What that means is that this is a course for both statistics majors and non-statistics majors. Typically, when I teach this course, we usually have about a half and half split. And at least from what I've seen from the grade, from the roster for this course, that's true again this semester. And so specifically though for this course here, the way the course is meant to be taught is meant to be for master's level statistics students, statistics majors that is. Now, PhD statistics majors often take this course too, and that's fine. But what I shoot for in this course is meant for these second semester students in our master's program. Now, for the non-statistics majors, this is meant for master's and PhD students from a wide variety of disciplines. A couple of years ago, I checked at the number of majors that we've had in this course, and I think we're at, I think it's about 20, just to show you of the diversity that we have in this course in terms of majors and also backgrounds. The key, though, for a non-statistics major, though, is to make sure you do have the required background. This should not be your first statistics course that you've ever taken. You should be comfortable with confidence intervals and hypothesis tests, for example, that you would get like in a course like Stat 801. Also, you should have at least a little bit of experience with programming, not necessarily with R, but just with some language so that you understand if I say, well, just the idea of actually writing computer code to do something. It doesn't have to be extensive experience, but just some experience. That will greatly help you out. Okay, so with that then, this is the syllabus here, and that's the end of this video.